This is the MADAS model VII Max. This particular one was made somewhere, I think, around 1916 based on the serial number. And so I have this apart, so I figured while I have it apart, I'll just go over the basic steps of the auto division mechanism on this. This is, the first calculator on the market with automatic division, so I'll just demonstrate that. So let me reset all this. As you can see from this part over, this machine looks pretty much like a standard arithmometer. So you got your step drums down here. You got your bevel gears up here that will drive the carriage. Notice that, as you can tell, but right now these bevel gears are actually in the neutral position. And normally on an arithmometer, these would either be in subtraction or addition mode. I'm not sure which way is which right now, but they'd be either up or down, based on whether you have the machine set to addition or subtraction. So then to move the carriage, you have to actually lift the carriage up and move it. Otherwise, it'll interfere with these. But in this machine, you don't, because they stay in the neutral position. Notice if I push the handle down, then they engage. If I release it, they disengage. So that allows you to move the carriage without having to lift it up. It just, slides naturally. And how that works is, on this side of the machine, which I'll show you in a minute, when I stand it up, there's a series of cams that will either push this back or pull it forward, depending on what you have this switch set to. So see, if I move this over and push the handle down, see, now they come down, versus if I push this the other way, which is the addition mode, then they come up. So let me pause this and I'll stand this up and show you that side of it. So this is that side of the machine here. And you can see this lever here, my weight balance would stay where I put it, so you can actually see what I'm talking about. This here, see, if I push this down, I can move either up, which pushes the bevel gears back, or down like that, which pulls them forward. So that's based on the setting of this here. You see that pushes a little cam there against it, or not against it, the other way. And that's important because this pin here is on a disc, which again, weight balance, cooperate please, or exposure I should say, not on. You see that little pin down there is on a shaft. These cams here are pinned to that shaft, and that shaft runs all the way through the bottom and is the division control shaft. You can see that shaft goes all the way out through. So that will make a revolution during a division mechanism operation and put the machine into either addition or neutral based on the division state. So if I move down to the bottom, you can see that a little bit. I also wanted to show this piece. See, this is that same division control shaft, runs all the way through. This piece here has two little pins that ride on that disc, and that disc has a little cam sort of dent in it that way, which will push this down as it rotates around. This is kind of an L shape, so you can see it goes up and then it goes over to right about there. If I wiggle it, you can see that moving. That will control a gear on the back. You can see it right up there. I see it wiggling there. I will control a gear on the back there that when that pops out, it will engage the carriage shift mechanism. So yeah, I think that's all I have to show on the bottom here. I'll flip this back down and then show some more. Okay, so now we're back down again. So one other thing I want to mention is this part over here is the division mechanism. And what's going to happen is, so right now this is in 0, which right now I have division turned off, but this stays in 0 all the time when it's not doing anything. 0 is a subtraction mode. So if I turn division on, that will, allow this mode control here, to control the machine. And then as it trips an overflow, this will rotate to 2, which is restore the overflow, and then it will rotate to 1, which is shift the carriage, and then it will rotate back to 0 and continue subtracting after shifting the carriage. And so as you can see, this is the bevel shaft that runs across the front, that drives all the step drums. and there's an extra gear over here on this end. Let's see if we can get some, there we go, a little bit of lighting anyway. Come on, stop doing that. That drives this gear right here, which is attached to another shaft that runs through here, but it has this sort of funny shaped gear right there, and that's is what steps the division mechanism. So what's going to happen is, I can probably show a little bit of this. If I switch division on, you notice that it puts the machine into subtraction mode and also slides this whole thing over here. And you notice that this slides into engagement with one of the carry trips. So when the underflow happens, you know, all these are going to be tripping all the way across. Of course, it's going to trip this one as well because it trips all of them. And this is going to trip the division mechanism. You see this piece here pivots. Underneath this cover here is a piece that comes up. And that is attached to all the way down there in the bottom. Let's see if we can get some light on that. You see that funny looking pin there? You can see that funny looking pin in that piece. That piece is what will rotate on that pin. So this will push up, that piece will rotate this way, and what it will do is it will pivot that piece. You see that funny hook looking piece there? That hook right in the center there will pivot into the path of the teeth on the division step wheel. You can kind of see the back of it, maybe. There, you can see how that's the back of it there. And when, I can't really show it, but you see that piece is a part of that pivoting piece. So that has another piece behind it that will pivot out, and as it pivots out, the piece on the other side, it's kind of like a fork, will push the tail here out with it, you know, keeping it against this piece in the front, and then that is attached to that locking piece there. You can kind of see it has a pin there, or you could see how it has a pin there that'll pivot. This finger goes into the path of this funny shaped division step gear, and that actuates the division step, you know, as part of this, like the state step. So let me see if I can show this here. So put it in division mode. You know, when you push the handle down, the machine starts subtracting until a underflow happens, which will trip this. Let me see if I can get a better view down here as I do that. This would help if this stay like that. So see, I pushed this down, so that's rotated the piece that we saw down there, which is pushed up on the tail of this other piece, which now rotated that piece into the path of the division step gear. So as I keep rotating, see, now it comes around. That little funny shelf there has tripped that. Now the division step mechanism has activated. It's being continually driven by this funny shaped gear. You can see there's also teeth on the little brass piece there. So it'll keep driving it until it has now moved to mode 2. As you can see, now the bevel gears have shifted up for the addition, and that's going to add, and then as it comes around again, and I don't think we'll be able to see this, but on the back, you can see it right next to the brass. So you see in the center of the screen, there's that pin there that holds that pivoting piece, and then next to that is a brass teeth engaged with the funny shaped gear. Then behind that, and next to that, almost against the cast iron wall, is a little lever that's also attached to that. So that's going to be tripped by a pin, because right now this is disengaged, right? So as I could turn the handle, see if you can see it not moving. So right now, that piece is not moving. See how the funny shaped division step drive is moving, but the actual division mechanism is not moving. Because there's no teeth engaged right now. Now what's going to happen is there's a pin on the back of the funny shaped gear. So let me see if I can get that coming around. Wish my white balance would actually be useful, or exposure rather. coming around now. See, that pin's going to trip that. It now pushes the division mechanism drive into engagement. You can see everything is rotating now. See, everything's rotating now. Now it's disengaged again. There's another pin down there ready to engage the next time, or another lever I should say. So right now it's in shift mode. So as you can see, that gear has popped out based on this cam down here. The cam's all the way down at the bottom, so you can't really see it, but that cam has moved that L-shaped lever to push this out. So if you watch this here, the carriage is now shifting. Those little pins drive the carriage. So the carriage is now shifting. And then, again, there's going to be another pin that comes through. Yeah, you're not going to really be able to see much, but that pin comes through, trips that to be engaged, or trips that to mesh with the teeth on the division step mechanism. And now we're back into subtraction again. So let me see if I can show this from above. So now we're subtracting, subtracting, subtracting. We're going to have a underflow, addition, shifting, back to subtraction again. And again, if we have an underflow. So let me show over here, if I can, this part of it here. So this will division stepping. So see how those cams move, push the bevel gears into the addition position. Now they moved again, push into the neutral position, and again back into the subtraction position. So I think that pretty much explains it. This piece here on this cam, that's just for the bell ringer. So as we continue around, let me trip it again. If you watch, that would ring the bell once and ring the bell again to let you know that, because that bell only rings when the carriage is all the way over in the home position. So that tells you that, you know, the machine's done, because there is no actual division termination on this. You know, if there's nothing that senses the carriage is, you know, at home and stops the division at the end, you know, if you keep cranking this, it'll keep going forever and ever. So you have to listen to that bell to let you know that it's done. And then, you know, once it's back into mode 0, you just let go of the handle once it's in the home position, and that's it. So there is no mechanical division termination. You just have to know to release the crank and stop, you know, once you hear that bell ring. So I hope that sort of, you know, explained how this works. Oh, and by the way, these two pins on the back of this gear, they engage with this fork, which is normally attached to the back of the carriage. You know, they you know, rise up in between those grooves there and push the carriage over as that gear rotates. So I think that's pretty much everything I really have to say about it. You know, as I pretty much everything from this side over is, you know, standard arithmometer, you know, as far as like how the carriages work and everything. And yeah, everything else about it. You know, basically they just added, because normally on arithmometers, this is kind of like an empty space over here. You know, that's where you got your little wooden box with your little window for taking notes. So they just kind of filled that in with the auto division mechanism. So yeah, I think that's about it. Hope this gave some insight into how the MADAS division works. So hope you enjoyed this video, and thank you for watching.